thank you very much, Professor Alysson, for sharing this session. Yeah, and all the students that connected, even we have this issues and challenges with the time differences. So at this moment, it's 10 a.m. in Mexico. This is where I am in Aguascalientes, in the center of Mexico. So yeah, and I want to talk to you about material resources and circular economy, and how to rethink waste, recycling, and resource efficiency. Of course, this is a big topic, and yeah, it's the whole world starts to understand that we have to do something about it. And yeah, I want to give you a short introduction to the topic and then give you some examples. So, and even we tried it before, and now it worked. So just to present myself a little bit, well, I'm now a research professor at Universidad Panamericana in the engineering department, and I'm here now for 11 years, and I'm the international coordinator of the IMAT program here in Mexico. So whenever you want to come by, you're very welcome to study at Universidad Panamericana. I have working experience as well as an engineering consultant in Munich and Cologne in Germany, and there I worked, well, there I entered in the topic of renewable energies and soil and atmosphere amendment. And yeah, do you see a volcano here? This volcano is, of course, Mexico has a lot of volcanoes, but I used to work in volcanoes. And yeah, to test some monitoring system, my working group in Würzburg in Germany, yeah, developed. Okay. So here's where we are. This is the right center of Mexico. We are, of course, in the south of the US. And here's the state of Aguascalientes. In the state of Aguascalientes, we have the city of Aguascalientes as well. This is why UP is Universidad Panamericana in Aguascalientes. We have another university site in Guadalajara and one in Mexico City. Actually, there's two in Mexico City now. We have around 15,000 students and a little bit more than 2,000 in Aguascalientes. So we are the smallest campus. Of course, we suffer from some challenges in the world: global warming, water scarcity, eutrophication. This is the image you see here on the right-hand side with the green lake. Yeah, there's too much nutrients in the rivers that go into lakes, and it gets accumulated, and then algae and other plants start to grow too fast, so no oxygen can go to the lower parts of the lake. And in the end, every life in the lake will die. And eutrophication is a really nice example of that we not having an equilibrium, no? And so there's too much on the one side and not enough on the other side. Of course, on the other hand, we have poor soils. Many people suffer from food insecurity, even though 1/3 of all the food in the world is thrown away. And of course, waste. No? And as you maybe know, waste is something that even shouldn't exist. No? It's just not, it's something at the wrong time, at the wrong place. And so what do you listen in the news? Yeah, so the news we usually hear about CO2 and that there's more CO2 from companies, from cars, and all the CO2 news lead us to a kind of vision that we call the carbon tunnel vision. And why we have to be aware of that, not to get in a carbon tunnel, is we might miss some business opportunities, of course, yeah, that we may have. There are so much more challenges than just the CO2 challenge. And of course, education, health, yeah, water, one of the biggest topics, ecotoxicity, yeah, inequality. And so we have to confront those challenges as well and not just get lost in a carbon tunnel. And so, yeah, so companies just risk missing out on important business opportunities, yeah, and eroding their long-term ability to create value. So at the moment, most of our companies and countries and states are following a linear economy. So we get a raw material out of the soil or from the forest when it's wood. We make a product out of it. It gets on the market, somebody buys it, somebody uses it, and when it doesn't work anymore for what it was produced, we just throw it away, and usually it ends up in a landfill. And this is the way it happens nearly everywhere in the world, in nearly every country in the world. But of course, the raw materials are less and less available in the earth, and we are getting them out with many risks, with many toxins. And this is why we have to go to circular economy, where our raw material in the best scenario is a secondary raw material, and we just try to use it again and again. Yeah, we make a product, we use it, and when it doesn't work for what it was made for, we try to get the parts from the product and make another product out of it, or just keep it, or do it maintenance or whatever, just to keep the material in the circle. So this is what we should do. Of course, this will only work with a good design of the product. When there's a bad design of the product, we cannot reuse it. When we have toxic material, we cannot reuse it, or we should not reuse it. So to think about economy, we can have a look at a game. So when we are playing a game, so what are you looking for? What is your goal? Yeah, usually we would try to win. So when I'm sitting there with my family, of course, I always want to win. But when we start when we start thinking about economy, there are two different types of games: the finite games and the infinite games. And in the finite games, the winner takes it all, basically. And in the infinite games, you just keep on going. Yeah, and there we have some resilience inside. And so you just recreate your creative you. When you fell down, you get up again, and you just grow and grow. And the idea is to outlast the competition and not win it. Yeah. Or include them, yeah, because circular economy as well is about a lot of communication and systems. And so in the finite game, though, the goal is to beat your competition, and the infinite game, the goal is not to beat it, yeah, just to outlast it. And in circular economy, resilience is one of the most important things, not only in circular economy, as well in life, yeah, to survive. And what is resilience? Well, it's the ability to jump back and start over again. And your company has to be as flexible as the market and as the consumer. And so you have to redesign. You have to get into transition. You have to watch out for new business opportunity, and just again and again recreate and get up again when you fall down. And so this is what we what we have to think about. And it's just like this old Greek saying that society grows great when old men plant trees. Yeah. And the shadow where they might sit in. Yeah. Okay. So, and I want to talk to you about planetary boundaries as well. And the planetary boundaries And this is a diagram, yeah, where we hear the orange sections. They indicate like a kind of overshoot of boundaries, like the climate change, stratospheric ozone depletion, yeah, ocean acidification. Yeah, here again, too much CO2 or into that is absorbed by the oceans, and it turns into carbonatic acid, and it finally dissolves many of the ocean life. As well, freshwater use, land system change, yeah, biodiversity. And so these are the planetary boundaries are ecological boundaries, yeah? And we have to take care to keep them low, just to make sure that life on Earth will go on, and it's more for the human being than for any other being. And this diagram was amplified to the donut dashboard. And it was an idea from Kate Raworth from the Oxford University. And she and her work group, they included a social foundation as well. And so we don't have just the ecological boundaries like climate change and land conversion, biodiversity, air pollution. We also include the human, the person, this in the social foundation. And so we have to take care of the people. We have to assure their health, their education. Of course, they need enough food. And just this way, a person can work properly and, of course, enhance the economy of your company. And so this is very important as well, and an interesting way to have a look at it. Yeah, and in the end, we just have to keep safe all this parts, the ecological part and the social part, and this way your company may prosper. Yeah. And when we talk about the donut diagram or the donut dashboard, of course, we have to look at the life cycle analysis or life cycle assessment. And companies can use the life cycle assessment, which is the most extensive method for assessing multiple environmental impacts. And it's associated with all stages of product's life, yeah, from the raw material to the final disposal. We have to look at it directly from the mine where you take it off, yeah, and then where does it go through, and be aware of everything, of all the toxins that are going out, all the money that it costs. And yeah, so here we have, I took a picture at from the landfill in Aguascalientes. It was a field trip with some students. And here the question is, what do you see? Yeah. And usually people answer, and in my mind it comes as well, like waste. Yeah, we see waste. But actually we should see something else. Yeah, we should see all the value we have here. We have a lot of paper, we have different kinds of metals, we have glass, we have wood, yeah, we have different kinds of plastics. Of course, we have to separate them. And when we are smart enough to separate them the right time, then we may reuse them. Yeah, you cannot just mix every kind of or different kind of plastic. You need to check, okay, can you heat it? At what temperature can you heat it? How many times can you reuse it? And so this needs a kind of management, organization, and of course we have to be smart to do so. So there are 5 areas of priority, yeah, for the circular economy in the European Union, and it's food waste, it's biomass, bio-based products, plastics, critical raw materials, and construction and demolition waste. Yeah, this is actually one of the most important ones. We are not constructing very smartly at this time. We did once, but now our buildings are made up of too many materials that are not only toxic, that as well are very difficult to separate. And so we should change, we really should start to change that part. So is it a resource or is it a problem? So this is what we have to think about. So here what we see is it seems to be waste, yeah, but it can be as well 1 ton of municipal solid waste, yeah, or 50 liters of petroleum equivalent, 600 kilograms of fertilizer, or just 400 liters of water. Yeah, it's just a choice. Okay, what do you want, waste or value? And nevertheless, yeah, we have too much food waste. 1/3 of all the food in the world is wasted. And this means, of course, we have less soil. This could have been used for planting food, yeah? So we have less food, and in the end, we have less money, yeah? And of course, I want to show you the butterfly diagram, because we have this beautiful butterfly shape with the biological cycle and the technical cycle, yeah? And consumption only happens in the biological cycle here on the left-hand side, yeah? It's where you have all the different cascades of agriculture, maybe biochar, and you can turn all the waste from agriculture or from organic waste, if you can turn it into energy, like biogas. Of course, you can do composting, even it's not the most energy efficient thing to do. You can just reuse it. You can use the fiber. We at our university, we are turning food waste into biopolymers. And so this is everything what's happening in the biological cycle. And the technical cycle, here we cover and restore products, yeah? And we have to try to reuse again, to repair, to remanufacture. And recycling actually is just a tiny little part of it, yeah? Actually, Mexico now, we have now a circular economy law, and of course it's a nice start, but when you have a look at it, it's basically recycling. It's not thinking in systems, but of course you have to start somewhere. But recycling is not a circular economy. Recycling is just a part, a tiny little part of circular economy. And of course, when we maintain products, when we remanufacture, we have to we need energy. And therefore, we should use renewable energies, yeah? And not just fossil energies. And so this is just, of course, well, sun is just for free, yeah? We just produce one-time solar panels or whatever you need to use sun energy, and then you start, yeah? And it's there, so probably humankind will die out before the sun. And so this is why they are called renewable, yeah? They are kind of unlimited sources, and the non-renewables, of course, are limited sources like carbon or natural gas. So renewable energies is solar energy, wind energy, even from the ocean. There we have different kinds, so just the waves or the whole mass of the sea, of the seawater, hydropower, like from rivers. And one of the renewable energies that, in my point of view, is not used enough is the biomass. And actually, this is a big source of energy that now is waste. Yeah, it's waste. We just throw it away. We pay a lot of money to get rid of it, to transport it to the landfills or wherever, instead of using it and earning money out of it. Yeah, and you have biomass everywhere, in urban areas, in rural areas, forestry, agriculture. We have biomass everywhere. Just have to analyze it. Okay, what kind of biomass is it? Is it a plant with a lot of water? Is it a plant with a lot of sugar? So when it's a plant with a lot of sugar, you can turn it into bioethanol. When it has a lot of fat, maybe you can turn it into biodiesel. When it has a lot of lignin, like the lignin is a compound you have a lot in trees. Yeah, that's giving the strong structure of trees. For example, you might turn that into biochar, and yeah, so there's a lot of potential in biomass, and I hope we will use it a little bit more and turn this waste into the different possible values we have here. So here I have a little video for you. Rethinking process of circular economy. So I hope you can hear it. Please tell me if you have
living systems have been around for...
Can you hear it? Do you have the sound? Yes, excellent. Thank you.
Yeah, we can.
Thank you, Professor. Thank you. Yeah, thank you.
Few billion years, and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food. Energy is provided by the sun. Things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
Okay. So it doesn't go on. Let's see. Okay. Okay, so what you just saw in the video, it's just the biggest challenge is like the system part. You have to connect all the different companies that are now separate. The carpenter here, the electrician here, the man from the mine here, and so we have to combine them and find a new solution. There are several schools of circular economy. We have Walter Stahel, we have cradle to cradle. I'm sure you heard about that, from Wilhelm McDonald and Michael Braungart. An interesting part is as well biomimicry from Janine Benyos. Here she's to make something a little bit more efficient, an energy system or machine or whatever. You might use the example from nature, maybe from you can use like, okay, you can check why the whale is swimming so fast, and okay, you check his wings, and then you say, okay, we adapt that to the wings we need in our wind turbine, for example. So it's really nice. Even you can adapt whole systems of how bees, for example, act in nature, and adapt it to society as well, and be more efficient in the end. There's another one from industrial ecology, from Livset and Thomas Gretel. And I'm sure you have heard about the Lovings, Emery and Hunter Lovings and Paul Hawken, and of course the blue economy system of Günter Pauli. Of course, it's not only about changing the world. In the end, it's economy, and we need business opportunities. By 2050, the cities will be home to 2/3 of the population. Cities will consume 75% of the world's natural resources. And of course, they will produce a lot of waste, more than 50%, and over 60% of the greenhouse gas emissions. And this air contamination is the reason for many accidents, and as well health issues, and even death, even in Germany, and so the cities all around the world are in a prime position to help scale up circular economy transition in a wide variety of ways. And many cities all over the world already adopted some circular economy strategies in many ways. So they have enhanced their waste system. They are working on sustainable buildings. And so we have some examples I want to present to you now. And first we will have a look at this video here, circular economy in cities.
By 2050, 2/3 of us will live in cities. Already, cities are where we consume 75% of our natural resources, produce over 50% of global waste, and emit up to 80% of global greenhouse gases. These are consequences of our linear take-make-waste model. But cities are also places which concentrate on innovation, education, finance, culture, and where people exchange ideas. Pragmatic and acting quickly, they play a leading role in politics and the economy. They can lead the way to develop a circular economy. The circular economy can help cities to thrive and become more livable and resilient, helping to meet urban priorities around housing, transport, and economic development. The circular economy can also help cities meet the Sustainable Development Goals and their climate targets. It starts with 3 principles. Design out waste and pollution. Avoid creating waste in the first place. For example, with products and parts created within cities where needed, using materials that can be reused, recycled, or composted. Making use of untapped space in buildings, transport, and using renewable energy to power the city, making them healthier and cleaner. Keep products in use. So products are no longer used just once. They're reused, repaired, and refurbished. And people gain access to the things they need, be it space, products, or transport, in new ways. For example, through sharing rather than owning, and connecting people to their neighbours and communities. And cities are planned so that materials flow. Regenerate natural systems so that valuable nutrients return to the soil and air and water quality improves in the city and in the countryside beyond. Ready to get started? The Ellen MacArthur Foundation's suite of resources help you take the lead and create a city fit for today. The time to act is now.
Okay, so here you see the cities are not only the places where we produce, where we need more resources, where we produce most waste, they're as well like the source of innovation, of creativity, and of possibilities in the end. Yeah. So what properties and conditions should the material have to be an opportunity as well? So as we have seen, so in circular economy, to keep a product in the circle, you need materials that need certain conditions. So what do you think? What conditions should a material mean? So if any one of you would like to add something here. No one? So I help you out here. And so, of course, non-toxic, yeah. And it has to be like Lego, no? Maybe many of you played with Lego when you were small, the tiny little bricks you put together, and it's very easy to get them. Well, you build something and then you can like destruct it easily, no waste, yeah. And this is how we should design our products, no matter what, yeah. If we talk about construction, clothes, or whatever, yeah, cell phone as well would be a nice example. So it has to be economically valuable, sustainable, social, and of course, life cycle analysis is here what we need. So the product's life from raw materials to final disposal. Of course, we have to think about climate change, human toxicity, yeah, ecotoxicity, water, yeah, in any way, yeah. So so here's the different kind of materials we have to take care about. And even though we don't stop, so many of the clothes we can buy in usual shops everywhere in the world are toxic, yeah. And of course, you usually know you buy something new and you should wash it before wearing it. And yeah, so it's very obvious that we are not designing in a way that's helpful for humans or for human health. So of course, we have to do something about it, be aware of it. Yeah, maybe you have some solutions as well here for a better design for clothing. It's not necessary to produce toxic fashion. Yeah, what we have directly on your skin. Yeah, the biggest organ we have. Yeah. And so we started, or humans started to buy a lot of new clothes, more clothes, more clothes, and just 15% of it is recycled or reused. So this is why the clothing is the second most contaminant material we have now in the world after petroleum, of course. So here we just have a look at the life cycle of a t-shirt.
Consider the classic white t-shirt. Annually, we sell and buy 2 billion t-shirts globally, making it one of the most common garments in the world. But how and where is the average t-shirt made, and what's its environmental impact? Clothing items can vary a lot, but a typical t-shirt begins its life on a farm in America, China, or India, where cotton seeds are sown, irrigated, and grown for the fluffy bolls they produce. Self-driving machines carefully harvest these puffs. An industrial cotton gin mechanically separates the fluffy bolls from the seeds, and the cotton lint is pressed into 225-kilogram bales. The cotton plants require a huge quantity of water and pesticides. 2,700 liters of water are needed to produce the average t-shirt, enough to fill more than 30 bathtubs. Meanwhile, cotton uses more insecticides and pesticides than any other crop in the world. These pollutants can be carcinogenic, harm the health of field workers, and damage surrounding ecosystems. Some t-shirts are made of organic cotton, grown without pesticides and insecticides, but organic cotton makes up less than 1% of the 22.7 million metric tons of cotton produced worldwide. Once the cotton bales leave the farm, textile mills ship them to a spinning facility, usually in China or India, where high-tech machines blend, card, comb, pull, stretch, and finally twist the cotton into snowy ropes of yarn called slivers. Then yarns are sent to the mill, where huge circular knitting machines weave them into sheets of rough grayish fabric, treated with heat and chemicals until they turn soft and white. Here, the fabric is dipped into commercial bleaches and azo dyes, which make up the vivid coloring in about 70% of textiles. Unfortunately, some of these contain cancer-causing cadmium, lead, chromium, and mercury. Other harmful compounds and chemicals can cause widespread contamination when released as toxic wastewater in rivers and oceans. Technologies are now so advanced in some countries that the entire process of growing and producing fabric barely touches a human hand, but only up until this point. After the finished cloth travels to factories, often in Bangladesh, China, India, or Turkey, human labor is still required to stitch them up into t-shirts. Intricate work that machines just can't do. This process has its own problems. Bangladesh, for example, which has surpassed China as the world's biggest exporter of cotton t-shirts, employs 4.5 million people in the t-shirt industry, but they typically face poor conditions and low wages. After manufacture, all those t-shirts travel by ship, train, and truck to be sold in high-income countries, a process that gives cotton an enormous carbon footprint. Some countries produce their own clothing domestically, which cuts out this polluting stage. But generally, apparel production accounts for 10% of global carbon emissions. And it's escalating. Cheaper garments and the public's willingness to buy boosted global production from 1994 to 2014 by 400% to around 80 billion garments each year. Finally, in a consumer's home, the t-shirt goes through one of the most resource-intensive phases of its lifetime. In America, for instance, the average household does nearly 400 loads of laundry per year, each using about 40 gallons of water. Washing machines and dryers both use energy, with dryers requiring 5 to 6 times more than washers. This dramatic shift in clothing consumption over the last 20 years, driven by large corporations and the trend of fast fashion, has cost the environment, the health of farmers, and driven questionable human labor practices. It's also turned fashion into the second largest polluter in the world after oil. But there are things we can do. Consider shopping secondhand. Try to look for textiles made from recycled or organic fabrics. Wash clothes less and line dry to save resources. Instead of throwing them away at the end of their life, donate, recycle, or reuse them as cleaning rags. And finally, you might ask yourself, how many t-shirts and articles of clothing will you consume over your lifetime? And what will be their combined impact on the world? When we produce TED-Ed videos about the environment, we often think about the young people who subscribe to this channel and how unfair it is that you're inheriting environmental problems that were probably set into motion long before you were born. The good news is that we see students everywhere making moves to meet the world's biggest challenges head-on. For example, in TED-Ed's Student Voice program, sustainability has emerged as a topic of choice in thousands of presentations.
Okay, so here we saw, well, the life cycle of a t-shirt. Yeah, we saw how much water you need. Yeah, nearly 2,000 liters just for one t-shirt, a lot of pesticides, toxic, and of course we saw that it's the second the second biggest polluter in the world, clothing. And so, yeah, we should rethink it. And there are different possibilities to avoid this kind of waste. So we may use biomaterials. Yeah, biomaterials are, well, we have to clarify what biomaterials mean. So bio usually can be like organic, that it's made out of some living system, or it might mean that it's biodegradable, or it might mean that it's both of it. So made of some living thing, usually plants, or biodegradable, both of it. Yeah. And so we have biomaterials made of fungi, biomaterials made of seaweed, we have biomaterial made of that are starch-based or from wood. And we can turn those into biopolymers or bioplastics and biochar. So here we have a diagram that shows different kind of polymers. And so on the left-hand side, we have the not biodegradable polymers, on the right-hand side, the biodegradable. And what it's in the top, we have the renewable raw materials, and in the lower part, we have the petrochemical raw materials. And what we see clearly here, and many people are not aware about, that we might have biodegradable polymers, also bioplastics in the end, that are made of petrochemical raw materials. So they can be mixed, but usually when we talk about biopolymers or bioplastics, we are thinking of biopolymers that are made of some organic matter, and that it's as well at the same time biodegradable. So what we have here in the upper right-hand part. So yeah, so the advantage of the petrochemical based polymers is they are of low cost, yeah, and they can be produced very fast. They have a high mechanical performance. That's really important. Of course, plastic is one of the things we really need in our everyday life. It's just a fantastic product, yeah. And there's a reason why there's so many plastic all over the world, yeah. Of course, it's a good barrier properties, good heat stability, yeah. On the other hand, we have the disadvantages, yeah. We have the environmental hazards. Everybody knows about bioplastic, all the toxins, all the BPR, and the softifiers, yeah. And so it's a big challenge for waste management, yeah, and the risk of toxicity for other materials, animals, plants, yeah, that are living everywhere in nature, in soil, is very high. And of course, we have limited oil and gas resources, yeah, with increasing prices. So the bioplastics, so they have a lower carbon footprint compared to petrochemical-based polymers, yeah, 4 to 6 times less. Yeah, and 1 kilogram of bioplastic resin produces about, well, half a kilogram of CO2, while petrochemical-based biopolymers produce 2 to 3 kilograms of CO2. Yeah. And so there are many advantages of bio-based, biodegradable polymers in comparison to petrochemical-based polymers. Yeah, and overall a higher production cost compared to petrochemical-based polymers. Yeah, they have a big potential for contamination of recycling and processes of other plastics. So this is why, well, we at our university produce bioplastics as well, and many other companies saw this business opportunity as well. For example, Seashell, yeah, they are developing commercial products made of seashells, yeah. And they're doing like what you see here, some kind of cups, but as well packaging, furniture, dishes, whatever you like. Yeah, and so this is a really nice example for a biopolymer. Here we have an example of a material that is fungi-based. Yeah, you just use mycelium, what is basically the fungi, and you cultivate it in a substrate of cotton. You put it in the right shape, yeah, and the mycelium combines with the natural fibers and forms a solid structure. You put it any shape you would like to have. You can just let it grow there. And the cultivation is stopped as soon as the optimal properties are reached. So you have the right shape, the right form, and you just stop the growing, you kind of kill the fungi, and then you just leave it there. And you can, well, have any kind of shape you ever like. So there's another example from a startup from Guadalajara, and they turned waste from nopal, what this is kind of cactus, into a new material. And of course, nopal needs very little water. It grows just everywhere in Mexico, where in the desert parts, and it's therefore very environmental friendly. And it has not any kind of the plastics from the old-fashioned way. Let's see, like this. And what's interesting about this startup, they made a kind of joint venture with a company in Germany, and they are buying their this material to produce bags and whatever, and they are well sold in Germany. So there's a business opportunity for both, for the people in for the inventors in Guadalajara in Mexico, and as well for the company in Germany that are producing the bags for selling. Here's another, well, you don't have only seashell bioplastics as well. There are bioplastics that are a little bit more stable, and even chairs. So here we have, let's see if that works, a small video from the Shell Works. So we have a really nice example of turning waste lobster shells into value. Yeah, and there are many other examples to do so. And so here's another example from DSM Niaga. It's a company from the Netherlands, and they produce mattresses. And mattresses usually are as well a really bad designed product, even they are very comfortable. They have a lot of different parts that are really difficult to separate. In some sense, they are toxic, and of course they are not biodegradable at all. And those mattresses from DSM Niaga, when you cannot use them anymore, you can just separate the different sheets, the different parts, clean them, and make a new comfortable mattress out of it again. A simple example of what we might do to save energy is Everdrop. So instead of selling cleaning products in a liquid way, they sell it in powder. And because everybody of us has water in the house, and they transport just the powder, so it's much less energy for transporting water you already have somewhere where it goes to. And on your own, when you buy it as well, it's very practical. The powder has nearly no weight, yeah, and you just use it, you mix it with the water in your house, and it's done. And so it's a win-win situation again. It's really easy way to use. Actually, well, as well in Mexico, we have many cleaning products in powder way, so it's already exists, yeah. And Everdrop, just a new company that prospers as well. So here's another business idea from Circus. They saw as well, okay, when many people have little kids, yeah, and you buy them one jacket or something, it's really expensive. They use it 1 or 2 times, and then the kid grew up, and then you cannot need the jacket anymore. Of course, maybe there's some cousin or the next child, but you cannot have infinite childs to give the jacket on and on. And so they have so this example for sharing clothes, you can rent the jacket with them. It's usually a good quality jacket from good quality brands, and you just rent the jacket for a certain time, and then you give it back. And this is as well just a nice business model. Another example for reducing waste is here from the architecture part from Catherine Larson, and we have this little video here. They're using
Hi, my name is Catherine Larson, and I'm an architectural technologist that works with seaweed. So as a designer, I'm really inspired by vernacular architecture. And when I moved to Denmark, I found out about this traditional way of building from this island of Læsø called seaweed thatching. And I wanted to create a modern update where you could build with it for the modern building industry. I saw another contemporary project by a firm called Van Kunsten called the Modern Seaweed House, where they used it in pillows as a cladding material on walls. But I wanted to create a modern interpretation of what the thatching process might look like and see if you could build with it. So I created a panel that you can use on roof and facade that acts as supplementary insulation, but also as a type of green panel. And I've been testing it for the last 1.5 years. And I just created a pavilion with it at the School of Copenhagen School of Design and Technology. When we heat up our buildings, we're using energy to keep that up. So we need thicker insulation to keep that heat from escaping. And what we're using right now is synthetic insulation mainly. But if you were using more natural bio-based solutions like eelgrass, it would create better ventilation in our walls and create a better indoor climate for us.
So here they just combine a non-toxic building material
Hi,
that's
my name is
completely circular economy. Here's an example of a building in the Netherlands as well, in Venlo. And it's a municipal building. It's very well, it includes all the parts you need. Yeah, it's on a long-term vision, it's economically efficient, it's totally sustainable, and it includes as well the social parts. So people that go into this building will not suffer from any toxics, they will feel comfortable, they will breathe clean air, they will have gardens, they have a water recollection system. And so this building in Venlo is a really nice example of how we should construct our buildings. Here is, well, it's just, which is an example of a building. It's built in Hamburg, in Germany, and they use, well, algae to produce energy. And so this way we can reduce very efficiently the energy costs of the housing. So it's here as well, an example, a program of a totally circular economy program from the city of Toronto. They're the ones to reduce, well, the single use and takeaway items, very common everywhere in the world. Yeah, they focus a lot on all the waste part. They try to reduce the waste production, food waste production, and every city in the world should implement such kind of strategies and waste strategy programs, and was to work towards a circular economy. Here's an example from the company of Arendt, and they produce furnitures for offices. And as you know, well, this furniture in offices, so there are a lot of clients, there are a lot of people there, and usually this furniture, yeah, it destroys or doesn't look nice after 2 or 3 years. And what does the company do? Well, they buy the new furniture, then after 2 or 3 years, they have to throw it away, and just to look nicely, yeah, for the clients that are coming by. Of course, this is a lot of waste. This is a lot of money. And so what Arendt is doing, they are like renting parts of furniture, and there you can just recombine it in any way, and you not only just, it does not look good again, and with a nice design, you will have new designs and possibilities of new designs as well. So because the sense of beauty changes as well, yeah, with time. And so this is a really nice example of a business opportunity for furniture here from Arendt. Of course, another example from mobility from Shenzhen. They had more than 16,000 buses, electric buses, yeah, and one of the first cities who implemented electric buses in their public transport system. And so to cut emissions, reduce noise pollution, and improve air quality. So this was the idea. And here I want to present you a nice example of carbon capture, and this is biochar. So one of my research projects is biochar. And so this product, you get it from a process, it's called pyrolysis. And pyrolysis is a kind of carbonization without or with nearly no oxygen. And the secret of biochar is what you see here in the tiny little pores. So this is like yeah, 5-star hotels for micro organisms like fungi and bacteria. And there are many, we have many applications and benefits from biochar. So it's we can use it in agriculture, or yeah, for the animal farming and in our soils. We can even use it as water filter. And in the end, it's a big advantage for economy. Actually, the Ithaca Institute in Switzerland, they are mentioning more than 40 applications of biochar. So here's an example when you apply biochar to the soil, well, biochar mixed with fertilizer. Does anyone has a question? Okay, so your plant will just grow much higher. Yeah, this is just a plant that grows with no fertilizer. B, you have a plant growing with fertilizer, and then when you mix the fertilizer with biochar and then introduce it to the soil, your plant will grow stronger, higher. You will have more plant, so economically very valuable. And because your plant is growing so strongly, those tiny little annuals, the plague will not have any chance like to destroy your plant. And so you need less pesticides. What's a big advantage as well here? So this is how your soil will look like when you mix it with biochar. So you will have it's something that's called terra preta. Terra preta is, was found first in the Amazonas region. And yeah, people there, they just did it naturally. They kind of, burned or pyrolyzed organic waste, mixed it with the soil, and the soil could produce much more food than the soil without the biochar, without the terra preta. At our university, we are producing biochar with the Kontiki. It's an open curtain kiln. It's a design from the Ithaca Institute from Hans-Peter Schmidt. It's an open patent, so anyone could just ask for it and produce it on their own. So we produced it. We asked for the patent and for the design, and they sent it to us, and we produced it here in the state of Aguascalientes, and now we are producing biochar at our campus. So you can use biochar in the industry, for medicine, for cosmetics, yeah, in construction, in food, in livestock, agriculture. There's many different applications, and as well it works as a carbon sink. Yeah, in agriculture it works as soil amendment. You can, well, it depends what you want to do. If you want to that your plants grow higher and bigger, you just mix it with fertilizer. But when you want to use it for soil amendment, like in a mine area of mining or something where you have heavy metals, it might absorb those heavy metals. When you introduce biochar into your soil, it will help to keep the water in the soil, and so it helps for water retention. You can use it as water filter as well. The food industry is stock fodder, medicine, so it helps for the digestion of livestock, and as well as an energy source. Yeah. In construction material and in buildings, yeah, it helps for it's kind of respiration of the building. And yeah, another research project we have at our university at UP is that we turn bio waste into plastic. So we use orange peel and mango peel, and actually the whole waste of the mango, even the seed and the kernel inside it. So that's where our first results, and this is when we had our first bioplastic. We have some papers published on it as well. And here, we have the masters. You can study this master in circular economy. You can study here at our university at UP in Mexico. It's Ingeniería de Economía Circular. So you can come over and study here a year as well with us. And so just to put it in a nutshell, what we need that circular economy works, that we can reduce waste and use resources in a better way is, so we need intelligent designs, we need to be creative. Very essential is communication and connection. And we have to keep in mind the whole systems. And maybe this is the most challenging part of all. So this is maybe the reason why it takes so much time. Yeah. So now I want to ask you, and I would really like that you to share your opinion. So what is missing for everyone to apply the circular economy strategies? Yeah, so we have some ideas somewhere in the world, in some companies, in some municipalities, even in some politics, but they're still missing a lot to apply circular economy strategies everywhere. What do you think is missing? So any idea from your side? So I tried to pronounce your name, Ruizen. What do you think? Okay, Ruizen, I did not pronounce well your name. Then Chinwan Tian. No? Okay, then let's see. So no ideas? Well, actually, it's that, no? We have to start think in systems, and we have to enhance our communication strategies, yeah, and work together. And this is the reason why it just needs more time. We have to rethink, we have to change even the culture part, no? And our cultures like to think separately, yeah? Okay, I'm doing my thing, I'm doing it good, I'm doing it until there, and what's happening around me, I don't care. And so we have to change this and get into this communication with all the other companies, with all the other strategies, with the politicians, companies, universities. We have to work together and show that it works. Many companies already apply circular economy strategies. It's easier for them. They have just, to think in their company, and they see and know they will have economic benefits by applying circular economy strategies. This is why they just do it. And so, well, here I'm finishing this lecture, and I want to thank you very much. If you have any questions, I'm here to answer them. And yeah, and then yeah, I'm giving the word to Professor Alysson. Good luck for your presentation, for your lecture, Professor Alysson, and thank you very much.
Okay. See you later, Professor.
Thank you,
Bye.
Professor.
Thank you, Professor.
Thank you.
Thank you.
Okay, gentlemen and ladies, I'm Professor Alysson. I'm glad we'll have this class here, and let's just move forward. Maybe we can finish a little minutes earlier, and I think you might want that so you can sleep. I know it's almost 2 p.m. in China and probably later in Japan, and okay, let's go. I'll follow the same theme as Professor Pia, and let us just go on. I'll have a brief presentation on my behalf. I'm your current Professor Alysson. I'm electrical engineer, master in biomedical engineer, 2 years of industry. Maybe you've heard about the software ANSYS. It's from structural and CFD simulations. I'm doctor in mechanical engineer with an oil reservoir rock models, 4 years as research, in the Paraná University, 2 years as professor, also in Paraná University, Federal University, and since 2013, I'm teaching at Universidade Positivo. Then I had 2 postdocs, and now since 2020, I'm also master and PhD professor. And you might think this guy is crazy because he had so much different learning experiences, but all of them were in signal processing. So that's my research area. Recently, also, I've been working with artificial intelligence, also signal processing and farm equipment. This one of my recent research I've been working with, it's about the Harpia eagle, and we are trying to differentiate the individuals of this specimen with using neural networks and trying to identify the individual, not the bird. The bird is easy. It's easy to differentiate from the harpia from another eagle, but we are trying to separate the individual. This one is individual A, that one is another harpia, and that one, and that can be very useful for the biologists. I've also worked recently with vertical farming and also small equipment for farm for small producers. And this one, it was a very nice tractor for soil preparation for small producers. By now, you are at spring because you are northern hemisphere. We in Brazil are in southern hemisphere, and our side of view is more or less like this one. Most of the tree leaves already fell off. It's really cold today, and the weather forecast in Curitiba for today is 7. It was actually 3 degrees today morning, and it's probably the most it will be 16, and without heated buildings. And I don't know if you can see me, but I'm wearing a jacket and also a thermal shirt in some below because it's really cold inside my classroom. It's common here. In Brazil, we don't have heated buildings for cultural reasons, and we who live here in the Brazil southern, we get very chilly inside the buildings. In Brazil, we actually write it with S, Brazil. We have more than 8 million of square kilometers. It's a really big country. It's almost the size of Europe, and it's half of the size of South America. Brazil, it's all both in northern and southern hemispheres. It has this small part here in northern hemisphere. It varies from 90th to 15th gross product in world, and also has 220 million people. It's a huge and populous country. The name Brazil means red like fire. It comes from a tree. It's pau Brasil or amberwood. It's this tree here, and the logs, when splitted, they look like this one here. It's really red, meaning red like fire. Also, even if we are a huge economy, we are not we are not as developed as we should be. I mean, when you look at our GDP per capita, it's small. It's smaller than several countries in world, and it's nice, but yet far away from developed countries. It's very heterogeneous in cities, which can be very challenging. You can see here a skyline view from São Paulo, which is our biggest city. It has more than 12 million inhabitants. And you can see here Serra da Saudade. It's one of our smallest cities, which has less than 1,000 inhabitants. So the contrast between these cities can be a challenge for the federal government. Brazil is divided in 27 states in 5 regions. And when you hear about Brazil, you probably think of this. You think of the Amazon rainforest and the Amazon River, or maybe you heard about Carnival and it's a big party, and you know it goes on TV, on internet, has lots of things going on about it, but it has diverse weather and culture. We also have views like this. This is São Paulo, where you can see a foggy sky and a very urban city. This one here, it's Florianopolis. It's another big city. It's in coastal. Actually, Florianopolis is an island. But you can see this type of view here is very beautiful. It's the Chapada dos Guimarães. It's in center of the country, and you really can go there. It's very nice place to hike and to go on, see waterfalls at several tracks here. It's a very nice place. And this is the same country. It's divided in 5 regions, north, northeast, center west, southwest, and south. North is hot and wet, northeast is hot and dry, center west, southeast, and south. It's kind of complicated. Temperatures can go from -10 to 45. It's a mess. In some of about Brazilian forests, we've got the Amazon rainforest. It's almost half of the country. It's around 3 million of square kilometers. It is wet. It's really wet. You probably heard of this jaguar. It's called onça pintada. It's Brazilian biggest feline, and it's a very beautiful animal. In the Cerrado, in the Cerrado biome, it's around 2 million of square kilometers dry, but it's also very fertile. And this is the lobo-guará, it's Brazilian wolf, and this is the tamanduá bandeira. It's anteater, I think the name in English. And that's a huge animal. It's a very beautiful one. The Atlantic forest, it's very degraded, and yet it still has more than 100,000 square kilometers. This is what it should be, it was originally, and the light green is the remnant. It's no wonder it has been devastated, because this coincides with the where Brazilians live today. So people took the trees to build houses, and that's where we live. But yes, we still have views like this. This is at Paraná, where I'm talking just right now. And you can take the train and look at on these views. It's very beautiful. We have the Caatinga biome. This is very unique and exquisite. It's very Brazilian. It's dry and gray, but when it has the first rain in the year, it gets wet and green. It's very beautiful. It also, the soil is very salty. It was a sea in previous era, and it has goats and has grains, and get this part of Brazil here. And there are several others. I could talk about relief all day long, but I won't take your time. We have the Pampa, we have the Pantanal with crocodiles, and this is the Brazilian alligator, jacaré-açu, and Brazil is way too diverse for a class. You gotta try coming here if you want to. We are a part of the IMAT network. And this is a Brazil's relief map, which explains why we are so diverse. Brazil is a hilly country. We call it Serra. And everywhere you go in Brazil, you have Serra or something. Bikes are not popular as daily transport. You might wonder why, because we are a hilly country, and it gets really hard to going somewhere using bikes. 55% of Brazilian population is in the coast, which is a large amount of people considering the size of the country. But that's expected because our history is made from the coast. Our colonization came from the coast. Brazil colonization, we used to say that everyone can be Brazilian because 80% of our colonization came from Portugal, Spain, and Italy, 15% from Germany and Japan, and we had lesser colonization from these countries here, and we don't have a standard face. I mean, everyone can be Brazilian. We are a mixture of all these countries here, and if you just arrive to Brazil, if you learn a couple of words in Portuguese, you'll be easily mistaken by Brazilian, even if you are not. And you might wonder, where are the indigenous population? It became miscegenated. This should be an Indian from Brazil, from the Northeast region, and this is an Indian from Brazil, from the North region. But we had Indian population, originarious population from the entire country, but they became miscegenated. I'm talking from Curitiba, which is in the southern of Brazil. Sorry. It's the 80th most populous city with almost 2 million people, and it's all around 4,000 inhabitants per square kilometer. Curitiba is known for its several parks. They are very beautiful. This one has this beautiful waterfall, this one with Ukrainian memorial, and this the most famous, the Botanical Garden. It was built from Dom Pedro II, Brazilian second king, and it's very beautiful. Also, Curitiba is known for its capybaras. You can see them everywhere, including at Universidade Positivo, where I'm working. Actually, I'm just in this building here, and this one is the library, and you can just go around and see the capybaras. They are just wandering around in the campus. Almost starting, please interact. I know it's early in the morning, but the class will be more interesting. We'll have some time for it. If you have any comments, please raise your hand. The topics. We'll think about the circular economy and waste destination theme. We'll talk about the North Development Bands theory and the per country implementation, and we'll finish with the Brazilian way. And let's make an agreement. I really would like to have a definitive solution for waste reuse, and I don't. You won't find it in my class, but I think we can think about it together. The main goal today is to think, and I will be really happy if after this class you have the you have the goal reached that, well, I thought about the topic, and that's my main purpose. Also, think yourself as a manager or a public mayor, not just an engineer. I know most of you are engineers and you are pursuing a master degree, but as engineers, we like technology, we like machines, we like production, but most of us will eventually do management. And so think yourself as a manager, not just an engineer. And that be in several levels, as a mayor, as a company head, or as a leader. And try to think yourself differently. So let's get started. Why do we need to worry about waste? And that's my first question. I don't know if you have ever seen that waste deposit, and people go there and the trucks bring the waste to there and just throw it away. Have you ever seen that? Please raise your hand, make a sign. If you have you ever seen something like that, or have you heard about? How do you do that in your country? One each time. No one has no one ever seen anything like that? Guys, please wake up. No? Okay, I'm glad no one has ever seen, but that exists. Have you a solution for that? I'll make like Professor Pia and start calling names. Ling Chang,
Professor?
you awake? Oh yeah, sure.
Professor, I've seen even like the worst part of this in my home country.
India?
Yeah.
Yeah, I do think India we should have some like Brazil. And this is a picture from Brazil. It's not from India. But okay, how would you solve that?
So currently we started having the waste segregation as it's done in Europe. Like we have the separate for plastic and separate waste for other materials, but we are still it's a long process. So but we are implementing it since last few years. So preliminary after COVID, it started in a lot of, so it started in good proportion after COVID, but yeah, it's still a long way to go.
I love it because you are really thinking as engineer. It's a very nice cause. Actually, Emmanuel, also thank you for your answer. You are also thinking as engineer because you said, "Oh, let's burn it, let's make energy," and okay, that's very engineer of you guys. But thank you. You are making the class more profitable. Okay, let's go on. I know we are talking about I'm talking about two engineers, so you are thinking about logistics, drug, waste management. And of course, we are talking about making money. I was very happy when Professor Pia talked about the limits of circular economy because all of us need to make money. And that's true. We need to make money. And let's check how to. Of course, it's a little more complex in any sense. Let's just look at this small plastic bottle. It came through lots of processes before becoming a bottle. It was the fossil oil, and then it came to prospection, it was drilled, it came to production, and then to refining. Then it became plastic, then it was filled with water, then transported, and came to a store where you can buy it and just drink it. And so it's a very expensive, not really, but it's too complex just to discard it because you drink the water and go to a trash bin and put it away. So it's not, we are not the first ones to worry about this problem here. Of course, the first Sustainable Development Goal is to end poverty. Target 1.4 reads by 2030, ensure that all men and women, in particular the poor and vulnerable, have access to basic services. Of course, it's not that easy. It's a global waste emergency. We have a very big problem on securing a regular and reliable waste collection service to 1/3 of the world population. Also, 1/3 of population have problems on municipal solid waste treatment. It just is not collected. So people would just burn it, not to make energy, not to make anything. They will just burn it because they don't have what to do with it. So we had this 9 development bands theory of waste development. It's a very interesting concept, and we'll get to it. It's about when you have no waste management, you are at DB1. You are starting this process, and the goal is to reach DB0 with circular economy. Whenever we are talking about circular economy, we are very concerned about how can we do that? Because we need to make money, and how can we implement it? So this is a plan for circular economy and using from zero to something. We will start our class in DB1 and we went our class in DB5, because DB5 reaches the SDG, and after DB5 you can read the paper. The paper is here. It's a very interesting paper, and you may read it after class. The municipal waste collection history, it can go from ancient times. We have records from 2000, before Common Era. We have records in Middle Ages and during the 1700s and the 1800s, and that became in Europe due to bubonic plague. All of us have heard about it, and also lots of cholera, which is yet common in African countries, but it's not very expected to be found in Europe, and so we had this during these centuries. It was a very strong motivator for municipal solid waste collection. After that, during the 1900s, it started to go to motorized refuse collection, and during 1950, plastic garbage bags were developed, and in 2000, automated waste collection systems. It all due to Global North laws. If you are not familiar with the concept, the so-called Global North should be the blue countries here, including Australia and New Zealand, and the Global South are the red countries marked here. And then in 2010, single stream recycled. In 2020, expansion of smart waste technologies. So beautiful, so nice. And the cause of such investment of time, of effort, and of money are disease. Humanity quickly understood that the wrong waste management meant disease or even death. There are several human parasites that could just kill us, and all of them are needed. A common cause of them is the wrong waste management. And the 3-2 roadmap challenge should be this one. It's a roadmap. It's a plan. It's not the solution. Of course, it's a possible solution, but we can use it as a simple plan to implement it, to go from zero to circular economy. I think I lost the presentation. Let me share it again. Okay, let's move. And the DBs are defined according to several criteria. Are DB1 to DB5 are the waste collection service coverage and the proportion of solid waste managed in controlled recovery disposal facility. So DB1 means no waste collected. DB5 means almost all of waste is collected and treated of some kind. And the SDG 11.6.1 is the proportion of urban solid waste regularly collected and with appropriate final destination in the total urban solid waste generated by cities. So this is the criteria we need to reach. So if every city in world reach DB5, then everything should be fine. Of course, it would be very nice if every city gets to DB0 and gets circular economy. However, the SDG goal should be all of us reaching DB5. And another point of view would be just exactly that. In DB1, we have no service. In DB5, we reach SDG 1161. In DB0, we reach full waste treatment. That should be simple, but it could be challenging. Do you remember I said that Brazil is a hilly country? We have this city here, it's Florianopolis at Santa Catarina. As I said, it's an island. It's an island really near from the continent, but still an island. And look at this relief here. It has lots and lots of hills. And sometimes the trash truck must go up in reverse because it can't reach the street. The street's so narrow and so inclined, the trash truck doesn't have space to maneuver, and it must go in reverse. The people will collect the trash, the waste, and then the trash truck will go down. So geography matters, and matters a lot. Another remark, the beginning is so hard because culture must be created and people must help. And spoiler, if you have worked with people, they won't. So we'll go just in the beginning of this class from DB1 to DB4 and we'll reach DB5. And if you have never seen that kind of waste deposit, have you ever seen this, the waste being burned and one guy just beside it working? Have you seen that?
Yes.
Really, Valentine?
Yeah,
Yeah, it's often
Valentin,
happened in my home country in Indonesia also, Professor.
Indonesia.
Mm.
Okay, thank you.
Hello, Professor. I think
Yeah,
it's
but
it's happened also in my home country, Mauritania,
yeah,
and I think it's everywhere in the developing countries.
yeah, in the global south, we are still developing, so it really happens. It should not, but it happens. So, a question about that. And as Professor Pia, the presentation crashed. Okay. Culture must be created, people won't help, and that's the same when we're talking about politics. The politician will not help. The politician tends to keep just everything like it is, because they've got in the public statement place, so they won't leave it. They don't want to leave it. If they don't want to leave it, they want to keep just like it is. Usually, an external agent must act. And back to the tree, DB6 and DB7 are different pathways adopted in Global North. 8 and 9 are future steps. So if you read the paper, you see that no one has still implemented for waste management DB8 and 9. They are plans. And DB0 should be no waste and everything used for everything is zero waste and circular economy. It's still a dream. It's not even a plan. But how can a city achieve that? Well, during the 70s, there had environmental legislation in the global north. It kind of worked, but it didn't work in south. The World Bank concluded the majority of municipal solid waste management investments came from, they didn't work due to poorly defined institutional structure responsibilities, poor cost recovery, insufficient technical and management expertise, and other problems as well. A riddle. What do politicians do when a law fails? They do a new law. It doesn't mean it won't work, but that was what happened. They made a new law about waste management for the global south with a beautiful double triangle that physical and governance should work, and yet it's not working. But there are several laws. And from now, we'll focus on early steps. So maybe sometime you come back to your country and maybe you'll be a public manager or a mayor, or you have influence, a secretary of environmental services, and you can implement that in your city or in your state. And now we'll call these poor countries undeserved, and the high-income countries try to go to DBs 8 and 9. But the upper middle income, they are trying to reach DB4 and DB5, but most countries, they are still trying to go DB1 or DB3. I'll show you 3 cases here. It's a very nice case. First here is Sweden. We won't have time to play the full video. If you want to play this full video here, this is the code for YouTube. You can pause the video after class during the recorded session and use this code to reach the video, or try to write Sweden's treasure revolution. You get to this video here. Let me know if the audio is working. If it's not working, just say it.
There is no sound, Prof.
Professor, I think it's not working.
Is it working?
It's played, but there is no sound.
Okay, let's try to share it again, because it's the sharing system that makes the sound works. If it's not working, we'll just try it again and share it with sound. Okay, that will work now.
Just think of a country that buys garbage from other countries, and its residents feel comfortable wearing secondhand clothes and taking bottles to recycling centers. Pretty weird, isn't it? Well, if you've already imagined a godforsaken third world state, then you're wrong. We're talking about Sweden, one of the richest countries in Europe, which has become the absolute record holder in recycling. So today, you'll find out how Sweden turns trash into gold. But before we begin, make sure you have subscribed to the channel and hit the bell icon to stay updated with future content. 1%. That is how much trash ends up in Swedish landfills. According to the Swedish Waste Management Association, Avfallsverket, Sweden now recycles more than 99% of household waste. The recycling system works so well that Sweden serves as an example for almost all developed countries concerned about environmental issues. Why does this system work? No, not because the Swedes are some garbage-eating aliens, or because waste can teleport itself into space. The system did not start yesterday. It all dates back to the 1970s. Sweden, with its harsh climate and total dependence on natural gas supplies, decided to make a radical change in the energy situation. Experts estimate that each Swede produced about 3.3 pounds of garbage per day. Given that 4.4 short tons of household waste is more than enough to compensate for the use of 1.1 short tons of oil, simple logic drove the Swedes to the only right solution. The country got seriously involved in waste recycling. The secret.
Okay, this is a very nice. It's a very nice system, and you can check the video later. Let's have about the middle one. It's Singapore.
Every year, the world generates more than 2 billion tons of trash. That's enough to fill over 800,000 Olympic-sized swimming pools.
About a third of the world's waste is being openly dumped or burned. This is a challenge we've seen over and over, where users are unable to pay for use of the system, or there's an affordability gap.
And by the year 2050, the amount of rubbish generated annually is expected to increase to 3.4 billion tons. As the rubbish piles up, no number of landfills and recycling programs can keep pace with this growing problem. So what's the solution? The waste management process comprises the collection, treatment, and disposal of waste. Solid waste can come from several sources, mainly from residential and commercial properties and industrial facilities such as medical, electronic, and construction waste.
With COVID, overall, we've seen medical waste increase about 40%. It's often the poor that are the most affected by lack of waste management services, whether it's because they're not receiving waste management services due to where they're living, or waste is being dumped by the communities.
Even as medical waste piles up, is a tiny fraction of municipal solid waste. Of the 2 billion tons of waste generated globally, 12% is plastic waste, but it's dwarfed by food and organic matter and paper and cardboard scraps. Once all that trash is collected, there are 3 main ways it is treated and disposed of: by burning the trash in an incinerator, using a landfill, or dumping it openly without any processing whatsoever. While 33% of global waste end up directly at open dumps, governments are increasingly recognizing that these sites are bad for the environment and can be vectors for diseases. Instead,
as you can see, Singapore is still treating the problem, and you can go on a video later, and it has more 10 minutes. And let's just check a small part of the problem. The problem here in
thousands of people risk their lives collecting trash in one of India's largest landfills. They sort all kinds of waste, even used syringes. In recent years, fires have become more and more common, threatening people who work here and live nearby. The Balswa landfill burned for 2 months starting in April. When temperatures soared over 110 degrees Fahrenheit in New Delhi. Sahabuddin lost plastic and scrap metal he'd been collecting for years. Firefighters extinguished the open flames after about 2 weeks. But people here are still struggling to breathe because they've lived next to the smoldering plumes the whole time.
उसकी लाइफ तो समझिए बहुत ही नर्क लाइफ है.
As garbage piles up and the planet warms.
Well, and now you've seen a part of the problem. So, you've seen that in India, also happening in Singapore, Do you think they will be happy if you forbid them to sell this trash? What do you think? Again, guys, wake up, please.
What does that mean to sell the trash, Professor?
Because people will collect like metal and recyclable waste from the dump, and they will sell this metal or the trash they collected. Look here, we saw it here just. This guy here.
Sahabuddin,
Exactly.
10 degrees Fahrenheit in New Delhi.
Okay, this one. He was, no man. He works in the dump and he's collecting
Even
syringe.
used syringes.
He's just collecting it. It's not like that he's taking these to a proper place. They are taking these to sell. Do you think they will be happy if you just close the dump and he loses his profession?
Professor, I think no one will be happy if it's taking their livelihood, like if they are like earning from this. But if let's say there's a system and then is given a proper like a path, like guidance
Disposal.
to work or something like a company, and then he's getting involved in that and working over there, I think it would have been way better.
Perfect, Summer. And that should be some part of our role as students, as researchers, would be not just to plan a thing to close the dump. Of course, an open dump is terrible. It shouldn't be there anymore. However, there are people working there every day, and people live from the money they make on the things they are selling. So they won't be happy if the dump is just closed. So there must have some kind of social service that goes there, work with these people, and then close the dump. That should happen in parallel. I don't know if I made myself clear, but so simply trying to follow the historical trajectory of the global north, that should be a mistake, because the global north had hundreds of years to implement the waste management collection, and the global south is not having this amount of time. We are trying to make things faster, so we can't not follow the same road the global north went. Recycling is occurring, but in two systems, formal and informal, both of them in parallel, because the municipality is collecting the waste. However, people are also collecting the waste and selling in some ways and making earnings of it. Both of them are happening in parallel. And the logical solution should be integrate these people that are working in informal ways to formal ways. They are work as a partner of the mayor of the municipality. Also, undeserved communities receive a service. The disease outbreaks will reduce and recycler have make a better livelihood. And if the waste stream is recovered, also the costs get better and the collection and disposal get better. And this is a plan that should be followed. So let's try to have reachable targets. When you are talking about DB1 in the lower of this table here, It's talk about new beginnings. We don't have collection of waste, or just a small part of the waste is collected. And then we must establish basic collection and establish operators for it, have treatment, have real equipment and adequate equipment. In DB2, more than half of it is collected and some of it is processed in a facility. So that's what I'm talking about. Here, we just don't have collection. Every person makes a destination for its own collection. Here, it is collected. Half of it is collected, but just 20% is processed. And what's not processed? What about the 80%? We'll go to open dumps, and it's just not processed. In DB3, the processing can go to 50%. DB4 can reach 95%. In DB5, almost everything is processed. It doesn't mean it's circular economy. It just means it's processed in some way. It can go to power plants to make energy. It can go to recycling. And yet it's not circular economy. But that should be great if we could implement that in the global south. And the municipality is responsible for that. But I'll go target by target, so because tables are not very nice in PowerPoint presentation. You can print that table or you can pause it, it's in the paper. But let's try reachable targets. In DB1, you must do the basic. Some collection is better than no collection at all. In DB2, you are starting to improve structure and spend more money. And that includes bureaucracy, because there are laws for everything, and the public agent must obey the bureaucracy, and that costs money. In DB3, more collection and have a plan to reach the 95% and spend more money. In DB4, we are almost in target. Diversify funding, sell recycling, sell waste, and that can go to thermoelectrics, like Emmanuel said. In DB5, that's okay. We are doing everything fine. Now let's reduce the costs. And yet, the municipality is responsible. I've put this picture here. That's from a thermoelectric in Germany. It's Abfallheizkraftwerk in Geiselbulach in Germany. And it collects trash and it burns and makes electricity. It's just one of many. It works really fine. Well, we won't have this 10-minute break. Let's go on, have some water, keep yourself awake, and we'll just go on. Let's get back to where we started. I've shown some plan, but let's tackle the global waste emergency. And many cities and urban slums and rural communities have little or no service. And the situation tends to worse because population is growing. Many cities in Africa and South Asia are projected to have their waste generation doubles even every 15 or 20 years. And that makes a huge problem. Somehow the problem is being treated because the UN Nations ODF offer support, technical assistance, grants, and sometimes loans. However, out of 147 countries between 2003 2021, 66% of the top 20 of the money just goes 17% for China, 8% for Turkey, and 7% to the low-income countries. So this money should reach the poor countries. However, only 7% of it went there for the countries that needed most. And so that's a big problem. And that's so unfair. And it is. It's really unfair. but 7% of the money that goes to the low-income countries, because these low-income countries have many problems before waste management. Because who here thinks that waste management is important? Everyone thinks, but someone can think differently. How's that? Because these poor countries who only got 7% of the resource had many problems. They had war, they have famine, they have politics and dictatorship, they have water availability problems, disease outbreaks, and not disease outbreaks that comes from trash. They have disease outbreaks that are happening just right now. They are urgent. They are not for future, because we can plan, we'll have waste management, and we'll solve the problem, and then the disease will go. No, the disease are happening just right now and need attention. They have gangs and they have drug traffic. For these countries, waste management is not the #1 priority. So that explains why just 7% of the low-income countries had this money, these loans coming to them. Because these other countries, they are very much more organized than these countries here. And yet, waste management is important. Here are some phrases that are some quotes that Ricardo Flores Magón or James Oppenheimer or the human suffrage using labor movement said, "Where there are roses, there will be bread." No one knows who said that first, but this quote is very interesting because it's not that waste management is a rose. A rose would be a garden, a rose would be cultural spots or parks or something, but it's necessary. And yet, all of those here are still happening. When we are talking about countries or cities that are already organized, we can have roses. But if we have roses, we also have bread. So all of the solution for several problems serious like war, famine, gangs, drug traffic, must run in parallel with waste management. We won't have a simple solution to waste management and let all of those problems run alone, because they won't be solved. And I know this is an engineering class, not a philosophy class. And we are not a social assistance group, but we must think. We are engineers. We are able to understand what nobody can understand. There are places that technology can't reach. Only our minds can reach. And your tool is your brain. We must think of solutions that technology can't, or at least technology alone can't solve. And you as engineer are a part of the solution. Politicians are not. We can act as politicians, but the true politicians, they are not a part of the solution. They are part of the problem. So think of solutions to these kinds of problems here. To these kinds of problems here. Think of solutions, because you can. But okay, let's get practical again, sort of, because we are not implementing that in a city just right now. DB1, we must have a deserving public policy. We must talk to the actor, hire a company who has trucks, or buy a truck to go there and collect the waste, facilitate entrepreneurs to enter and stay in the sector and making money, making waste a valuable resource. So we'll have a healthy, clean, and prosperous city, because people are used to live in the middle of the waste. They are used to, and we must change that. That's the DB1 goal. Probably this is the hardest part of it. DB1 and DB3 are to develop the capacity of public authorities to plan next stage, to grow infrastructure, dividing city into zones. A city, the waste will not be collected evenly in the entire city. A part of it will have it collected first, and then the next, and then the next, and then the next, until the entire city had waste collecting. And so the DB3 have an expansion plan. After you divided the city, you know where to start, and then in DB3 you have an expansion plan, so the entire city has waste collection. DB4 have a fee collection plan because the municipality money is limited. Therefore, they need more money to expand. And I know no one like it, but we'll have taxes. And DB5 structure, waste must go somewhere, so it's integration with other urban environmental services. And those are simple parts, but main goals of this plan. And what's our role as engineers? In DB1, we are entrepreneurs and planners. Nothing is really ready. Everything must be done. You can own the company that collects the waste, or you can be a planner to help the municipality to reach the plan. In DB2, we are working with logistics, planning, costs, and innovation. In DB3 processes, we can elaborate with the lawyers the processes to help to process the waste, reduce the costs, and more innovation. In DB4, we have new models, environmental licensing, that's also in the role of an engineer. And in DB5, plans, and more innovation. That means lots of technology, not only technology, but also technology. Another example in 2021 in Kenya, 65% of low-income residents reported disposing nappies or diapers in pit latrines. Also, extended sanitation and waste collection in parallel. I just like to remark that sanitation gives no votes. It's an underground work, but gives no votes. Let's see this video.
আমাদের বাড়ির ময়লাটা আমাদের সমাজের ময়লাটা আমরা 10টা পরিবারের ময়লা একখানেই ফেলি, ওখান থেকে ওগুলো পরিষ্কার করা হয় না, যে ময়লাগুলো থাকে ওখানে পৌঁছে যায়, কাগজ, পলিথিন, প্লাস্টিক, আমরা ওগুলো পুড়াই দিই। ময়লা ফেলালে ওই দুর্গন্ধ বেরোয়, বাচ্চারা অসুস্থ হয়ে পড়ে।
সাতক্ষীরা কনটেক্সটে যদি বলি, পুরুষের তুলনায় নারীরা বা শিশুরা কিন্তু বেশি অ্যাফেক্টেড হচ্ছে, এবং এর ফলে যদি অব্যবস্থাপনাটা হয়, এটার যে স্মেল, ব্যাড স্মেল, এবং এটার পলিথিন বা অন্যান্য যেসব আইটেম যেটা আসলে অপচনশীল, সেটা পোড়ানোর ফলে সেটার যে গন্ধ বা ধোঁয়াটা আসছে, সেটা কিন্তু বাড়িতে অনেক সময় প্রেগনেন্ট মহিলা থাকে, অনেক সময় বয়স্ক লোক থাকে, শিশুরা থাকে, এবং নারীরাই সবসময় অবস্থান করে। সো এটার যে ব্যাড ইম্প্যাক্ট সেটা কিন্তু নারীদেরই গ্রহণ করতে হচ্ছে পুরুষের তুলনায়। সো আমরা বলতেই পারি যে আসলে nariraj beshi affected.
Na majirani, umejua mwingine anaweza kuja anamwaga takataka tu, na hapa tulikuwa tuna manage tu kidogo kidogo kama wenye wanaishi karibu na takataka, mimi na huyu jirani, kufagia na kuchoma choma. Niseme last month tukapata hii kampani ya nini inaitwa gasi ya poa, hiyo yenye ni but now unaweza peleka hata kiti ukae urelax tu hapo kidogo.
Parce que wàllu mbalit la il suffit que nga ne bujumaan laa rek am na feneen fu ñu lay féetalee dañ lay xeeb wala ñu am feneen foo xam ne ñu ngi la fay féetalee quoi mais daan sa doole la da ngay xëy suba moo nekk liggéey boo xam ne da ngay xëy suba for jaay
বলে পাশে যাওয়া যাবে না আমাদের সমাজে আমরা খুব অবহেলিত কিন্তু কেন আমরা অবহেলিত না আমরা যদি সেই শহরে না থাকতাম তাহলে মানুষ এই শহরে মানুষ বসবাস করতে পারতো না একদিন সাথে আমরা ময়লার কাছে অফ করে দিই তাহলে শহর একদম পরিস্থিতি দুর্গন্ধিতে মানুষ এই শহর ছেড়ে পালাবে তাহলে আমরা সমাজের কাছে আসলে আমরা উচিত থাকতে পারবো না এখন আমরা কি সমাজে আবর্জনা আমাকে আবর্জনা পরিষ্কার বলি আমাকে আবর্জনা হয়েছে কিন্তু শহরে নাকি না আমাকে আমার প্রতিষ্ঠান পাবো না আর আমরা উঁচু চলতে পারবো না সমাজে উঁচু চলতে পারবো না আমাদের তো সমাজে উঁচু চলার অধিকার আছে
ବୋତଲରେ ରହିବ ଏଇଟା ଜରିରେ ରହିବ ଏଇଟା ଗୁଡ଼ିଆରେ ରହିବ ଏଇଟା ଗୋଟେ ପ୍ଲାଷ୍ଟିକ ଏଇଟା ଗୋଟେ ହବ ଏଇ ଯୋଉ ଜରିଟା ବି ଅଲଗା ଟାଇପର ହବ ମାନେ ଏଇ ଜରିଟା ଅଲଗା ଇଏର ହବ ତାପରେ ଏଇ ଯୋଉ ଲୁହା ଫୁହା ଗୁଡ଼ା ଲୁହାରେ ହବ ଟିଣ ଗୁଡ଼ା ଟିଣରେ ହବ ଏମିତି ହେଇକି
comme ni nga ko gisee nii rek damay ñëw for dajale ba mu bëri nga trier maanaam boo ko gisee mooy vient nga def doo bujumaan du sànni lu ñu sànni rek soxla na ko.
biteel mbalit yëpp rek ay ñam yi xam nga nit ñi moom bu nekk bi kër bu nekk mbalit bu nekk lañ ciy def.
আমরা শুনেছি আমাদের পাশের এলাকায় পৌরসভা থেকে গাড়ি এসে ময়লা পরিষ্কার করে নিয়ে যায় যদি খুব তাড়াতাড়ি আমাদের জন্য ওই সুবিধাটা হতো যদি এভাবে কেউ 20-50 টাকা দিয়ে পরিষ্কার করে দিত আমার জন্য আরো ভালো হতো সেটাও দিতাম আমার জন্য ভালো হতো আরো পরিবেশটা ভালো থাকতো
kazi ya takataka yanisaidia sana vile mimi jinsi najionea nishanisaidia kwa maneno mengi naona vile jinsi pia ya kuelewana na kila jirani jinsi ya kuongea na kila mtu tena yanisaidia na inapata pia naweza kuongea na watu katika lugha nyingi kama pia wamefurahi pia mimi wanaacha kama nimefurahi
আমরা যে মানুষের উপকার করতে পারি যে শহরটা পরিষ্কার পরিচ্ছন্ন রাখতে পারি এটা নিজেদের কাছে খুবই ভালো লাগে কেননা যে একটা মানুষ সকালবেলা বাড়ি থেকে বাইরে দেখে যদি নোংরা পরিবেশ বা রাস্তায় একটা কিছু পড়ে যাচ্ছে এতে মানুষের অসুবিধা হবে বিধায় আমরা যে মানুষের যে উপকার মানে যে ময়লা পরিষ্কার করে যে শহরটা পরিষ্কার রাখি নিজেদের কাছে খুবই ভালো লাগে
And that's very interesting because that guy said waste collecting is not about waste, it's about people. It's about changing the people perspectives that the community must be kept clean and people just don't know how. And when we are going from DB1 to DB5, we should make early no regret investments. Because sanitation gives no votes usually, but it must be executed. And the same for waste collection. This is São Paulo. It was one of the first cities I show you with big skyline and buildings and very beautiful. But this is also São Paulo. It's the Vietnam slums in the neighborhood of Jabaquara. And these pipes here, they are just throwing waste in this small river here and these houses here, they have no waste collection. So they will just throw everything in the river. And it's of course, it's not a nice way of living. And if you just go there and make adequate toilets, and they will be nice, but during the process of excavation and putting tubes, it's a problem. People are not happy on it, so it gives no votes. Sanitation gives no votes. Therefore, the politician they are just going away from the problem. They don't, but it really must be approached. And the process from DB1 to DB5, extending waste collection, use diverse operator models. There can be central, because the waste can be collected in one step, larger vehicles go door to door, and then go to a recovery or final disposal facilities, or they can use two steps because they have restricted vehicular access. The waste generator go to an area, and the truck go to that area, and they get together in the truck, take that away to another point. And then support, adapt, and follow the plan. Engineering technology is not a main problem. I know we want to solve everything with the technology, but technology is not always the solution. People are the solution. And as engineers, it's not our main force. I know we work with technology, we work with complex problems, but we must, in the end of the day, we are working with people. Actually, just right now, as I'm talking to a computer, but behind that computer watching me, there's a person. And this person has problems, this person has concerns, and we, after the master degree, we go home and have the problems of the community. And all of them, some of them will be solved with technology, but most of them will be solved with people relationship. And that's what we are talking about waste management. Money, politics, and culture are problems. Circular economy may be a consequence, not the main goal. And I know it's very strange when we are talking about a circular economy class, but it's solving problems that circular economy will happen. It's not just, oh, let's make circular economy our main goal. No, let's solve this guy's problem, and then circular economy will happen. And we have just done the minimum, because DB5, it was a DB5 plan. The idea would be DB0 after DB9, but DB5 reaches the SDG. And for a poor country that has nothing, or a poor city, undeserved city that has nothing, DB4 is great. And that would be a 5 to 10 year plan. It's not a plan to reach in a couple of years. It would be very difficult to implement in an earlier time period. We won't reach 1 dB per year. So if the DB1, it's the part where we are just talking and planning, would be hard. I would plan to have like 3 years to DB1 and then expand year to year in a 10-year plan to reach DB5. And it's possible. It just takes money, and money makes taxes, and taxes come from the people. But when people see that the city is clean, it's very nice. I'd like to talk some of the Brazilian way. It's a simple case. It's not something very complex. It's not the global solution, but definitely a solution for those people who are there collecting waste and processing waste in their houses. In Brazil, we have recycler cooperatives with appropriate structure. So they won't process the waste anymore at home, and they won't have problems like rats or diseases. They will have an appropriate infrastructure with uniforms and gloves and appropriate resource. And they also will have some bins to put the waste in appropriate devices, and also selling it in a better negotiation than people to people. Instead of that, they will get together and sell it, have better negotiations and making more money of it. Also, this takes creative problems. Recycling is a available source of money. It's a big source of earnings. So in Brazil, we have this incredible profession called wire thieves. They are stealing copper and from a hot line. I mean, it's hot here. It's not unconnected from the system, but this guy is here and he is trying to cut this wire here, which is hot, and he can be electrocuted. But it's hardly impossible to identify because they will go to inside to up in the pole. They will come here with a very long knife and try to cut it, and we'll get the city without power because this guy here is stealing the copper. And it's really hard to identify where the copper came from because copper has lots of value in recycling. So in Brazil, we had this structure that helped a lot. These ladies here and this guy here, everyone in the cooperatives. The other hand is that guys like this one who are thieves that should be in jail, but they're selling copper, and well, it's almost impossible to identify them. We have finished the topics, but the class is not over yet. I'd like to since we were thinking since the beginning of the class, and I'd like to thank you for participating in it. Let us think for a few moments more. Waste is a very complex problem. It won't be solved with simple solutions. It's complex and involves agriculture, industry, transportation, social sectors like education, environment, health, rural or regional development. All of these sectors have interests and sometimes conflicting interests about waste. And solutions must take in account all of these sectors. DB theory is a plan. It is a plan from going to zero waste collect and disposal to proper waste disposal. But it's not a definitive solution. And it can go as in management projects. It can go from simple details to macro plans. You as engineer must know how to use this tool. This is another tool. It's like ISO or Six Sigma or lean manufacturing or even circular economy. Those are tools. You can use them the way you wish. Even more, they are strongly dependent on the country needs because culture matters so much. As engineer, we do technology, but there are laws and culture. What do you need? What does your country need? What does your municipality need? And that's how we treat waste management from zero to circular economy. And also culture matters a lot. For example, Bill Gates proposed a couple of years ago this machine that supposedly can clean wastewater and make it pure water. And I just like to say, would you drink of it? Actually, we do. The water we drink comes from a treatment plant station that supposedly that cleans the waste and make pure water, and we drink it. Culture matters because it's sort of easier, but would you live like near a nuclear power plant or a waste collecting facility? Both those decisions are not easy, and there's no easy way out. Sometimes we make things better for a part of the people and make things worse for part of the people. As researchers, it's not our role to make everyone happy. It's our role to make a solution for some topics. And the topic we are dealing today is waste. Somehow, human presence impacts us on nature. We need to treat waste because we are generating waste. These resource gatherings have impacts But how do we reduce this impact? What will come next? There's no easy answer. Every time someone reaches you trying to give you a simple solution, it's not working. Everyone wants to save the planet and the environment, but why do countries and companies keep polluting? Because it's merely cheaper not to treat waste than to clean it. A speech will not solve it. It's not about some little girl from global North that will make a speech in United Nations and thinks that everything is solved. Nothing is solved. Turn the waste into a business will solve it. And I know it's not a very profitable business, but it is profitable. So let's make waste into a business. Let's do research. By now, I hope you are thinking, man, how am I gonna solve this? Maybe you are thinking, man, I waste my 1 hour of my time thinking about a waste management plan. You don't have to solve all of this, at least not all of this, maybe a small part of this. I like this quote from Andy Weir in his book, Hail Mary. It's a weird feeling, scientific breakthroughs. There's no eureka moment, just a slow, steady progression toward the goal. But man, when you get the goal, it feels good. That is our research. We are doing research, solving problems that can be small, that can be big, but sometimes they take a lot for us to solve. And when we do, it feels really nice. We talked about all of these themes here, and we focused most of our class in the non-development bands theory. I really would appreciate if you would read the paper I told you about. We look at a poor country implementation in Kenya and some of the Brazilian way to solve our problems. And for every team there's hope. I mean, I know when we look at the problem seems so big, but there is solutions. There are solutions, and the solution goes on. It goes through us as engineers and as future managers. And if you allow me, yesterday is history, tomorrow is a mystery, today is a gift. That's why it's called the present. It's a quote from Master Uguay from Kung Fu Panda. If you haven't seen that, go to sleep, and when wake up in your free time, watch it. It's really nice. Here is my contact info. If you'd like to contact me later, we have some times for questions. Professor Pia is not here anymore, but if you have any questions, you'd like to take it now, or you can email me. I'm also open to researching signal processing if you'd like to, okay? Well, guys, that's what I had for my class. I had 10 minutes for questions, and also we had Professor Pia finished earlier, so the class is finishing earlier. From the guys in East, I know that's valuable time for sleeping. Okay? Have any questions?